If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
All right, so let's take a look at some miscellaneous games. So, what are the basic aspects of these more miscellaneous games? So, you're essentially in these miscellaneous games, you're going to have a couple of different variations. So, what are the characteristics of the grouping related games, and what are the characteristics of the sequential related games? Okay, so let's just take a look at their basic characteristics in general of these more miscellaneous games, the ones that are not in the same, that don't easily fall into the same categories as the ones that we've just gone over. So the first thing is that they're very rare. The vast majority of the games that are have been published and that have been on the test are going to be one of the aforementioned types that we've gone over. The various sequential and grouping and combination and with multiple movable or multiple structural sets. So that's going to be, most of these games, and chances are that those are the only games that you're going to encounter when you take the test. In fact, most of these miscellaneous games that are different from those have appeared actually in the earlier tests, including the unpublished tests, the ones that have never been put into any of the collections of 10 tests or anything like that. However, there have been a couple of examples in some of the more recent tests, so you want to be aware of them. The difference with these miscellaneous games as opposed to the other ones is essentially going to be in the nature of the structural set. And for the more grouping type miscellaneous games, they will conform to what I call a shuffle type of structure, and for the sequential miscellaneous games, it'll be more of a branching type of structure. Okay, so let's go into more detail into the specific kinds of variations for the grouping and sequential, starting with the grouping ones. So, in terms of the shuffle type games, their information. So we have the game on the right, we'll get to it in a second. But to sort of basically set it up, the most common variation for these miscellaneous games is the shuffle information, where the structural set is a grouping set with a given distribution, and the rules are going to ask you to shuffle or to redistribute those movable elements. So it's generally concerned with the distribution that you'll end up with after a certain amount of steps. So you're given a particular situation, with this particular arrangement, they rearrange it, and after each step you're concerned with that particular redistribution or rearrangement. So it's essentially a grouping game, but the key difference is in the rules, where you're rearranging the movable elements and you're generally switching them with one another. So as an example, take a look at what we have here on the right. We're told that there's 4 dogs, A, B, C, and D, and that they guard houses 1, 2, 3, and 4 in that order. What that means is that dog A is assigned to house 1, dog B is assigned to house 2, dog C is assigned to house 3, and dog D is assigned to house 4. So that's the initial distribution. That's what I mean, that you're given a particular distribution. So you start off with an assignment of dogs to houses. Continuing with the game, it says the assignment of the guard dogs to these houses changes each night according to the following conditions. And that's where the shuffling comes in. So you've got A to 1, B to 2, etc. And then the rules will tell you how you're going to, or what the redistribution is going to be. How you're going to shuffle up the dogs with respect to the houses. And if we look at the rules, so how exactly are you going to do this redistribution? So there's one possibility, which is given as the one with a colon, is that you might be asked to have A and B trade houses and C and D trade houses. So that's one possibility in terms of the redistribution. So if you're given with A being in 1 and B given in 2, and then after you incorporate that first rule, you'll have actually B, A in 2 and B, B in 1. And the same thing with C and D. The other possibility is that B trades with whoever is guarding house 4. So those are your rules for redistribution. You start out with A, B, C, and D in 1, 2, 3, 4, and then the game in the questions is going to have some combination of rule 1 and 2. It might ask if you if you start off with rule 2 and then you do rule one, how many steps will you end up, after how many steps will you end up with uh, dog A in house 3, for example? Or is it possible for dog A to end up in house 4, and what kind of combination of rules would that lead? That's what the shuffling is. Distribution, application of certain rules to redistribute, and then after each redistribution, you have a rather after each application of the rules, you have a new redistribution, and that's what the questions are going to be about. So, for example, here you might symbolize this, you might diagram this, sorry, by writing out here on the left we have A, B, C, and D are our elements, and then we have our structure on the right, 1, 2, 3, 4, and I've drawn in A, B, C, and D in terms of how they are going to start out. And the rules are that A and B trade, C and D trade, so that's rule 1, that's one possibility, or rather that's the first rule that is applied to this distribution, and the second one is that B and 4 are going to trade. So what would a new distribution look like if, for example, the question asks what is the possibility of, or rather what is a potential possibility once you apply both rules? And so that would look something like this, for example, because if you apply the first rule, then A would end up in 2 and B would end up in 1, and C would end up in 4 and D would end up in 3, because they would simply switch. But then if you do apply the second rule to that, 1 then 2, B would trade with whoever's in house 4. Since we said that C would have ended up in house 4, and we said that B would have been in house 1, you trade that, and now you have a new distribution. This is what is called a reshuffling after the first step, where that step has you apply both rules in that order, first 1, then 2. So this is what you'll be asked to do with these games. You're given a distribution, and then you're given rules to how to redistribute, and then you're asked, there could be a variety of questions about what it would look like after, both rules for distributing, one rule for distributing, just one multiple times, etc., etc. It depends on the game, and this is something we'll go over in the specific game that we do for this lesson. So this is an example of what a shuffling type miscellaneous game is. Now remember, it's essentially a grouping game where really just the weirdness is in the way that the movable and the structural interact with respect to having initial assignment and then being asked to be reassigned. And these games can actually sometimes have sequential aspects to them as well. So an example here would be if these houses 1, 2, 3, and 4 had a sequential sequence, and then either the rule or the question might ask what would you need to do? Like a rule might say that, for example, B could trade with whoever is directly to their right or something like that. And the question might ask, what is the furthest to the right that a particular element could go or something like that. It would involve that element of relative positioning in a ordering sense in terms of left to right. So these are the shuffle games, and they're essentially grouping games with a different approach to the to having an initial distribution and then having rules to change that initial distribution up. The other variation are the branching type of games, and so like I said, as I did with the other one, we'll take a look at the game in a second, but let's take a look at some of the basic information for what I mean for a branching game. So this is another common variation. Here it essentially asks you to draw connections between the elements in a set. Now these games are generally going to be concerned with the structure of connections between the set of elements. And you can think of it as a sequential variation with a tree diagram. That's what I mean by branching. So there's going to be connections between the movable elements, but it won't be in a straight line like a basic or like a standard sequential game. You're not looking at the overall sequence in terms of left to right. It's going to have a sequence that has maybe initially one start point but multiple endpoints in terms, so it'll look like a tree diagram, or it'll have branching off at certain points. The overall sequence is not going to be what's important. You're not going just from left to right. You're looking at the different individual connections that make up that tree diagram. So looking at what we have here, we see that a family on vacation is visiting 5 towns. Looking at the game above on the right, and the 5 towns are A, B, C, D, and E, and they're on vacation. So each town has at least one road connection to another town. Okay, so let's take a look at the game over on the right, it says that a family on vacation is visiting 5 towns, A, B, C, D, and E. And each town has at least one road connection to another town. Okay, so here we see that we're dealing with 5 movable elements, but we see that in between those elements, there's going to be different types of connections. So it's not that just A connects to B to C to D to E or something like that, that there's only one connection from one town to another and they connect in a sequence, from left to right or something along those lines. There could be multiple sequences in multiple different, or rather multiple connections, multiple different ways of getting from one letter to another, for example. So the first rule says that A is connected to at most 2 other towns. So we know that we can have potentially A being a part which branches, or an element which branches and connects to 2 other elements. Then it says that C and D are directly connected, so we know that there's one connection between them. And then the last one says B and E are not directly connected. So looking at it in terms of the diagram, we have A, B, C, D, and E, but we're not sure exactly what it's going to look like in terms of the structure, because it's not simply a sequence. If we look at the rules, or symbolizing the rules, the first one says that A connects with max 2, so we can symbolize it like that. The next one we can just draw C and D directly connected. And the last rule, we see that B and E are not directly connected. So the way you would be asked to deal with these in the questions is you might, for example, be asked to figure out what the actual connections between them might be. And a potential diagram could be something like this, where A connects to C, C connects out to E and D, and C connects out to B. So what do we see here? We see that this satisfies the rules. A connects with a max of 2, but in this case it connects just with 1, so that's fine. C is connected to D, but also with E and B, because we're told that each town has at least one connection to another town. What we don't know how many it could have in total. So you see, this is not a sequential game. We're not trying to figure out the sequence of A, B, C, D, and E. We're trying to figure out their connections to one another. And a question might ask something like this, or it might ask something like, what is the shortest way that you can get from A to B or from A to E, given that C and E are also connected? So it might say something along those lines. The key thing is that there is a relationship of, in some sense, of sequence or of connection, but it's not a linear relationship. It's a tree diagram relationship. It's a branching relationship. These are also relatively rare, but the basic thing is you want to remember that there are some sequential games which will have you create these kinds of tree diagrams, branching diagrams, where branching just means, as I've been using it here, where a particular element can have multiple connections to multiple elements, or it can have connections to multiple elements. Now with these, the structure could also have grouping aspects to it. For example, the places in the tree structure could be thought of as groups. So for example, you might say that there's 3 different types of towns, and so that a town is in the first type of town is of one size, the second type of is another. So A might, this family can only start in the largest town and it can end up in the smallest town. So you're also not only trying to figure out the connections between the towns, but also, for example, what kind of connections can be grouped together. So in summary, the miscellaneous games are actually very rare and have appeared generally in the earlier tests, although keep in mind the most recent tests have had a couple of examples of the shuffle type games. There hasn't been a branching game in a long time. The shuffle type games ask for a rearrangement of an initial distribution with each step, with each rearrangement, and the branching type games ask for connections between the different elements in a tree-like structure.